Let's continue section 6.4, dividing polynomials. And here's our first example using synthetic division. First things, we need to make sure that the problem is in standard form and that every power is represented. So we have the second power, first power, and this would be x to the 0 power. So we have the constant at the end. Down here we have x to the first power and then the constant. So everything is represented and in descending powers. Then we identify c, and remember we're taking the opposite of what we see here, so it would be -6. We then are going to take the coefficients of everything in our dividend. So 1 is the coefficient here, 5 is the coefficient here, and -6. So 1, 5, -6. You then leave this line blank and draw a line. The process involves 3 steps. You're going to bring down one time. So we bring down once in this synthetic division process. Then you are going to multiply and add repeatedly until you are done. So we bring down the first item and write it here. Then we are going to multiply the divisor by this number. So -6 times 1 is -6. We put our result here. You then add 5 and -6 is -1. You then multiply -6 times -1, you get +6, which you put here. You then add and you get 0. So notice we brought down the first item and then we repeated multiplying and adding until we were done. The number that is written in the right-hand corner will be your remainder. So in this case, there's a 0 remainder. Now we need to insert the variables that we are going to use in our final answer. Here are the coefficients of our final answer. We need to put back in the letters. Notice we ignored the letters to begin the problem. Now we need to put them back in. Well, the degree of your answer, your quotient, is going to always be 1 degree less than your dividend. So this was x squared. The degree of our final answer will be x to the first power. So we would insert an x here, and then you would continue to insert as necessary as you move down. Well, we started with x to the first, so the next item would not have an x attached to it. If we had started with x squared, we would have then had x and then a constant and so forth. But anyway, our answer here is going to be 1x minus 1 with a remainder of 0, or simply x minus 1. In this example, we start off realizing that we need to put everything in order. So the highest power is written first, 3x to the third, then x squared, then x to the first, and then the constant. In the divisor, it would also need to be in order, which it is. Once you have that taken care of and every degree is represented, you then are going to identify c as being -1, and then you're going to write down each of the coefficients in your dividend. So 3, 7, -4, and 12 is what we write here. Leaving this line blank and then beginning the process of bringing down, multiplying and adding. So we bring down the first item, 3, and copy it here. We then multiply -1 times 3 and get -3, which I put here. Add 7 and -3, you get 4. Now multiply, -1 times 4 is -4. You put it here. Add -4 and -4 to get -8. Then multiply -1 times -8 to get +8. Add 12 and 8 to get 20. Remember, this is going to always represent our remainder. So now we need to insert the variables. These are the coefficients of my answer and the remainder. Well, the highest degree in the problem is 3. So my answer will always be 1 degree less than what we have here. It will always be 1 degree less. So instead of starting with x to the third, we're going to start with x squared. So we insert an x squared here, and then what would follow x squared? X to the first, and then no variable. So we have a +3x squared, this is a +4x, a -8, and then a positive remainder of 20 over the divisor of x plus 1. Remember, as I said before, always to write your plus or negative sign, whichever it happens to be. This happens to be positive, by itself, not in the numerator with the 20. We need the 20 over x plus 1 to be separate from the negative 8. And we separate it by that plus sign. All right, taking a look at this example, we have 4x squared minus 9. It's in order of powers, but there is a power missing. Notice that there is no term of x to the first power. So we put in a placeholder of 0x to the first power. The denominator is fine. And remember, to do synthetic division, the denominator has to be in this form of a binomial. So we identify c from the problem as being a positive 2. We identify the coefficients as 4, 0, and negative 9. Notice we do include that 0. It is a placeholder. Then we begin the process of bringing down and then multiplying and adding. So we bring down the 4. We then multiply 2 times 4 to get 8, and we add 0 and 8 to get 8. We then multiply again 2 times 8 to get 16, and we add negative 9 plus 16 to get 7. Remember, this is always the remainder. All right, inserting the variables, we look back at the original problem to see that the highest power was 2. We're going to go 1 degree lower than x squared would be x. So we insert an x and we write our answer out. 4x plus 8 plus 7 over the divisor of x minus 2. All right, let's take a look now at a theorem. This is a statement that has been proven to be true. The remainder theorem says if a polynomial p of x is divided by a binomial of the form x minus c, then the remainder can be found by finding p of c. So if we wanted to know what was the remainder of dividing the entire polynomial by, let's say, x minus 2, we would be able to do that by just plugging in 2 to the function and calculating what the result would be. So the remainder theorem allows us to come up with the remainder rather quickly without going through the entire process of division. So this is something that is used in pre-calculus. You are trying in that course to find something that factors into the polynomial evenly. So they're using the remainder theorem to see what would give them a remainder of 0, which would mean that that binomial would divide into this evenly. And so they have to try many different numbers, and they need a quick way of doing that. For us, we're going to go ahead and apply this theorem. So if we want to know what this would result in if you divided by x minus 2, in other words, c is 2, which they present to us here, then we can simply just calculate what p of 2 is. And so notice here what I've done is plugged in a 2 everywhere there was a variable in the problem. So function notation, which we've seen before, we plug in a 2 here, here, here. So we have this. Following the order of operations, we do the exponents. 2 to the third power is 8. 2 to the second power is 4. And then doing the multiplication, this is what we end up with. And then adding and subtracting, we end up with 14 being our remainder. So if we had actually gone through the whole division process and divided this by x minus 2, we would have come up with a remainder of 14. So in other words, x minus 2 does not divide into that evenly. Here's another example. We have this polynomial given to us, and we want to know if you were to have divided by x minus 1/2, would it be, what would the remainder be? So we just plug in c as being 1/2 everywhere there's an x, plugging it in. You can use your calculators, or you can calculate by hand. 1/2 times 1/2 times 1/2 times 1/2 would give us 1 over 16. This would be 1 over 8, and this would be 1 over 4. Then notice in green I canceled common factors, so 4 goes into itself once, into 16 4 times, so we get 1/4. 2 goes into itself once and into 8 4 times, so we get 1/4 again. And then I went ahead and subtracted and added as we went across. Many of you have the fraction key on your calculator that looks like this, and you could use that to assist you here. So negative 1/4 minus 4, we would need a common denominator if we were working this out by hand, and that common denominator would be 4. So this 4 over 1, let's say, would become we'd have to multiply the top and bottom by 4. We would get 16 over 4. And so -1 minus 16, that's how we get the -17 over 4. Or if they ask you for a decimal answer, you would divide -17 by 4 to get -4.25.